Okay, I think I should start, right? Okay. Hello everyone. Nice to be here. Thank you all for coming. I'm Kostas Papageorgiou and I work at Voxxed Days Athens. Today I'm going to talk to you about TALOS. Well, TALOS originally was a bronze giant, the first robot in history, that protected dancing squids from invaders. In our case, TALOS is a tool that protects us from bugs going on production. So basically it's a framework that helps the QA team to execute automated tests. In this presentation I'm not going to dive into deep technical details. I'm not going to share with you any class diagrams, flow diagrams, nerd stuff. We don't have the time for that after all. I'm going to try to focus on the reasons that made us build it, the good things that came out of it, and some things that could have done better. In other words, I'm going to try to share with you our overall experience with TALOS. So first of all, let me introduce you to Optasia, our company. Optasia is a global fintech leader that enables the lending of micro and nano loans through our platform. We are operating worldwide and we provide 30 million, more than 30 million new loans on a daily basis to more than 500 million end users. Our Optasia platform is based on the microservices architecture and is designed to support the business needs of our clients through minimal configuration and project-specific code. Here you can see a high-level architecture of how we deliver a project. You can imagine the complexity. We have many different projects, and most of you, like developers or QA, I think you can imagine the complexity of having the versioning dimension added to this problem. That is basically the versioning of every gray box you see here. So that complexity brings us here. Why we need TALOS? Well, apart from the fact that 2 years ago, when we decided to leave the monolithic approach for software, and we had to move on with microservices, and we need a new testing solution for the stack, there is more on that. Not only we had to find a way to test a bunch of different microservices, but at the same time, we had to find a way to test our actual product, our entire service that we deliver to the client. Imagine that if we change one configurable parameter anywhere, or if an API is triggered with different inputs, that these things result in different behaviors. Different behaviors need to get tested before we can deliver our service. Moreover, we wanted our testing solution to grow along with our platform. And by growth, I mean either adding new microservices under testing, or new features under testing, or even the existing features we had, the impact they have on other components we haven't tested before. And that's the entire concept here, to test how anything affects everything end to end. Now we've seen why we need TALOS, and you're going to do the job. Let us see why you couldn't fit anything that's already out there to our needs. Well, at Optasia, every project that we deliver before it reaches its final production environment, or even after its launch, lives in many different environments. These environments are coordinated by another system we have built in-house, CCS, and that is our Central Configuration Server. So we needed a solution that could adapt the testing code to the underlying environment, the entire setup of microservices with their configuration. Moreover, we wanted to organize our test code and our test cases in a way that would give us the benefit of reusability and eliminate the copy-paste that we hate as much as possible. For these reasons, it felt easier to make something new rather than trying to modify what's already out there to fit our needs. And to be honest, at Optasia, we love building new stuff from scratch. Okay, here we are. So what is this TALOS exactly? Well, we said it's a framework for the QA guys to run automated tests. The backend lives inside the PHP platform we have, the multi-purpose PHP platform. And the testing code is written in Python, and it's maintained and built by the QA guys. From the web UI, The QA team can create test cases, can set configuration for projects, can switch between projects and execute tests, and stuff like that. And the most basic key features of the backend are that it detects the environment and adapts the code to the underlying environment. And we've added one other key feature lately. No more than a year ago, we understood that we wanted to simulate how our product behaves in the future. Either we talk about the interest and the charges a loan has in the future timeline, or the user experience they are giving to our customers. We wanted to find a way how we could simulate this behavior in the future timeline. So, the most obvious solution would be adding another key feature in TALOS, that is time travel. Seems cool. I don't know, but for you, what you think, but it is cool for us. Because TALOS gave us solutions to some problems we knew we had, and some problems we knew we would have once we would roll out the new microservices platform. One of the biggest things that we were targeted all along is to have reusability. So that the QA team, the only thing that we have to do was to be working on the project requirements and configure the platform to run the test, and not keep copy-pasting the code again and again, but using the same code that already exists. Moreover, we haven't managed only to have a layered solution for the code, but for the test cases also. Now we can support regression or sanity or smoke tests that are built like Lego bricks. Of course, we can have exceptions for all these cases because some projects have some project-specific scenarios, and we can support test cases for these cases as well. It will be even cooler when we reach our second milestone, that is integrating TALOS with our new CI and CD procedures, tools, and pipelines we are building, and finish the entire dream of CI/CD. The good things become even better because TALOS gave us solutions to some problems we didn't know we had. And the most important is that we haven't foreseen how fast our platform would grow. Imagine that when we started the microservices platform, we only had 4 microservices. Well, today it's a whole different world. We have actually 5 times that. And now we know that tomorrow it's going to be also different. Having TALOS there to support us for all these different setups, for all these different projects, unspeakably saved us tons of work. Moreover, it also motivated the QA guys to learn to use Python. The guys from QA were very happy and very eager to do the extra mile and achieve more and more stuff using Python every day. And another good here is the time travel, because we didn't have that from the start, but when the time came, TALOS gave us a clear and transparent solution to the entire QA team by solving the problem we had. Okay, now the other side of the coin. Things that we could have done better, but to be honest, they made us better at the end of the day. We understood that sometimes there were misalignments between the developing team and the QA team about the delivery of some features. We also understood that our documentation was left behind quite often. I think we all agree that these issues existed before TALOS, okay, for sure. But now having an automated platform that runs automated tests, the impact these issues have is far greater. One other thing that we did wrong is that we trusted that the QA guys could keep up with all the patterns and all the conventions we have designed for the testing code. But this didn't happen, and so we ended up with a small chaos in the code after 2 months. So we had to rewrite it. And this time we did it together, experienced developers along with the QA team. One last thing is that the experienced developers also have made some bad designing, and we haven't write the test case modeling in a good way. So we wrote this. We rewrote it in order to achieve the modularity and the reusability that today we are proud of having. So far, that is our experience with TALOS. As final words, I would like to say three things. First, as we see from the previous slide, if you want to make an omelette, then definitely you're going to break some eggs. Meaning that you don't have, that most probably you're not going to make it in your first try. You have to keep trying and make many iterations with it, like we did. Second, you don't necessarily have to use high-end or high technologies to do the job. For us, simple PHP and Python scripting do the job. And last but not least, if a problem seems too difficult to solve, or the solution you have in mind costs in a way that you want to pay, you may think to transform that problem. For example, in our case, when we were facing the many different projects issue, the most obvious solution would be to keep separate testing codes for every project, so the effort would be given on copy-pasting and maintaining all these different stacks of code. We didn't like that, so we have changed that to a problem of maintaining an entire platform that could fit every project needs. Thank you for your attention. I would love to hear any questions if you have, so please don't hesitate. Yes, please. Okay, I'm gonna try to explain it as much abstract and fast as I can. No, I don't have one. You create the test cases. You can then combine the test cases to small, big groups and create small tests that would be run quickly. The code is a library written in Python, and there are parts of the there are parts of the code that are applying to specific microservices. So, I must tell you about test cases to understand how the code works. The test cases are organized in a step model. This is actually, we took that actually from the behavior framework. So there is the preparation of a test, the execution, and then the assertion. For each step, there is a definition that matches the code that is applied to each microservice, if there is any impact on a microservice regarding the preparation, execution of the assertion of the test. The framework chooses the appropriate version of the code that fits the appropriate version of the setup that is deployed out there, and it executes it without the need to put human hands on it and choose what you should run. And of course, that is done with the help of the other tools that have built the standard configuration server that provides all this info, not only about the versions of the microservices deployed, but also giving the configuration they have, so the framework will know what features needs to be tested and what behavior should be checked. No. The version is how to say it? It's be given on the fly. When a microservice is deployed, but it cannot be deployed without declaring itself to the standard configuration server. What version is it? What environment it is? And what's the revision of the configuration it currently has. Oh, yes.
How simply initially try to make the different things work together and find out how to solve these problems. really personal when you take a decision of what you're going to do or what group is going to do something in order to help the whole process. So, what was it like? Did you have a guy to orchestrate the whole tech discussion there? Because in my experience, there are like many meetings with the people from different groups and
Okay.
I mean, there are many barriers in our profession, like front-end guys, back-end guys, QAs,
Yes.
DevOps. So
I understand the question. Not only the developers had to wear the shoes of the QA guys, but also the QA guys at the end they had to wear our shoes to understand how we interact the code, how we maintain it, and how we move forward. The orchestrator of all this coordination is sitting right behind you. It's our head of engineering and currently our CTO. But after a while, we did it on our own. We did it on our own. Me from the web team, along with my team, of course, interacted with the manager and the entire QA team, and we were working closely as much as we could. So that was it. Okay, thank you very much for attending.